Hi, everybody. I was thinking about integration by substitution the other day when I did that last video. I was thinking about how it did not have integration by substitution, and I'm thinking if you only have a two-question exam and they're going to have you integrate, obviously, they're not going to have you integrate a polynomial. They're going to have you integrate something like integration with substitution. So I feel like we should have a slight review on this. Um, just a bunch of random problems I came up with that hopefully will build your confidence in integration by substitution. Okay, so let's see here. Let's do this one. So clearly it's nasty. I can't use a calculator. There's no bounds. I can't use math 9. So I definitely have to show my work and integrate with substitution. So I'm going to let u be 25 minus x squared. So du dx is negative 2x. Okay. Careful over here, rearranging these terms out. I'll do it really slowly. So I bring over the dx, and then I think I ultimately need to solve for dx. So dx is equal to du divided by negative 2x. Sometimes I jump steps from here to there, but all right, so now when I come over here, I'm going to have a huge bunch of replacements. This x is still there. Now, instead of having this to the 1/2, I now have u. So it's u to the 1/2. This dx is right there. So it's du over negative 2x. So perfect. The x's are going to cancel. You need that to happen. And I'm left over with a 1 over negative 2. Got left over u to the 1/2 du. Okay, so now I have a simpler integrand that I can solve. So I'm going to add to the exponent. So adding 1 to 1/2 gives me, 3/2. And then, okay, so then don't be afraid to go to the side of your paper and have to figure this out. So negative 1/2 divided by 3/2 is the same as multiplying by 2 over 3, which means the 2's are going to cancel, and I'm left behind with just a negative 1 over 3. So, I mean, you just go over here if you have to. Negative 1/2 is being divided by 3/2. So that's negative 1/2 times 2 over 3. And then that just leaves me with this. Okay, anyway, back over here. Oh, plus c. And then in the very end, you just want to replace back what you had in for u. Okay, that's pretty good. Let's go to the next question. We'll change color. Okay, so again, I look at this and I think, oh yeah, there's an inside, there's an outside. Nothing's outside, but what's inside is x cubed plus 1. So I'm going to let u equal x cubed plus 1. Du dx. So maybe you guys are just watching. Sometimes just watching math is very satisfying. Maybe you want to, take out some paper and do this with me. It's your decision. But they are going to get progressively harder. So please don't just be like, I'm going to stop the video right now. I actually really want you to complete the video, because towards the end, I do trig ones, and I'm going to do inverse trig ones, which my prediction is you're going to have nasty trig and inverse trig, because why not? So anyway, please stick around. Okay. Okay, so moving this all around, I can solve for dx. It's du over 3x squared. So I kind of just did that in my head because I can. All right, so over here we have u squared, and then this is du over 3x squared. And then I go, wait a minute, there's a problem here. because you can't do it this way. It's not canceling, all right? So I needed you to see that this can't be done. So can't be done, at least not with substitutions. You know what you have to do is I would have to literally like FOIL this. Oh my goodness. So I would have to be like, write this as 2 copies. Oh my, which are they going to do this? I've seen this before in multiple choice, but they're not going to have you do this for, you have 2 questions. This is not what they're going to do. So you'd have to literally FOIL this out and then just do it like a polynomial. Okay. So, I mean, I'm not going to finish it, but I will at least write a little bit of it out. And then, so when you do this particular problem, you add to the exponent and divide, add to the exponent. I guess I am finishing it. That's a 4, so that becomes 1/2, and then plus an x plus c. I guess I did finish it. Okay. All right. That was just unfortunate. Couldn't use substitution. All right, moving on. All right. So one of the places for substitution to show up a lot is also with e. So this is just something we should always know. E to the x is e to the x plus c. Okay, that's just a fact. So just a good little piece of information. Is that purple? All right, so let's let u equal -3x. Du dx is -3. Solving, I'm going to bring over the dx this way, and then ultimately dx is equal to du over -3. So sometimes when I look at this, I think, oh, what am I off by? Because you're off by this -1/3. Anyway, I'm going to come over here. It's e to the u, and then du dx is now du over -3. So in essence, I'm literally integrating this, which just becomes this. Okay, and then you just sub back in your u. But I tell you, there comes a time as you progress with substitution like this, you get kind of quick with it, and you're like, oh, I'm only off by a -1/3. I'll just stick that in front. Eventually you'll get good like that. All right, so like looking at this, I might not quickly be able to figure out like what I'm off by, because you're not off by a 1/2. You're actually off by the reciprocal, which is 2. I don't know. I don't want to chance it. Don't chance it. You have like one shot at integration on this exam. So I think, and again, over here, things get a little, you can't just be like, oh, it's du over 2. It's not. It's cross multiply this, you get 2 du equals dx. So that's what I'm replacing over here. Remember, you're replacing what dx is. So this is actually e to the u, and then dx is 2 du. So actually, what I'm going to rewrite it like this. It looks a little weird with the 2 there. I don't know. As much as you want to go fast, this is a comfort zone over here. All right, and then this is just 2 e to the u plus c. So 2 e to the x over 2 plus c. I was off by 2, which is the reciprocal. I don't know. Just be careful. Just watch and practice. Okay, moving on. Maybe we can go a little quicker here. I don't know. Let's see. See, look for little tips. Like, look, the derivative, if I let u be x squared, I see my derivative 2x. I see an x, so I'm psyched because those x's are going to cancel. I still get left over with a 2, but all right, moving things around over here. Dx is equal to du over 2x, so I come over here. That x stays. This is e to the u. Dx is du over 2x. I'm happy my x's are canceling, but I'm left behind with that 1/2, totally okay. The integral of e to the u is e to the u. Oops, not that. Where's my eraser? Okay. I'm using a pen, and it's a little awkward, but I think I'm getting good at it. Okay. E to the u plus c. So, I don't know. I'm not chancing it. If I have an integration question, oops, that doesn't look good. Let's not do that. I'll just leave it. I don't know. Okay. So looking over here, I'm thinking, man, I'm only off by a negative. I'm not going for it. This would just be negative e to the negative x plus c. I don't know. Anyway, sometimes you can do that. Sometimes you might need to do it out. Okay, let's do some trig. So I hope you're still with me. All right, I look quickly and I'm like, okay. Oh, first of all, we need to remember that we need to, you know what you're going to need to do is I would have a note card next to you on the exam with every trig derivative. And so sine goes to cosine and cosine goes to negative sine. And you're going to have think of it as it's so weird. You're going to have open notes. So you would have every derivative in front of you, every theorem in front of you. You're going to have all these things all around you, printed, ready to go for you to quickly access if you need it. Okay, so back over here. I'm going to integrate. Well, actually, I'm going to let u be 3x. du dx is 3. dx is du over 3. Again, see, I'm off by a third. The integral of cosine is when you go the other direction. So derivatives are going from left to right. Integrals are right to left. So this is going to be the integral of cosine is sine of oops, I think I should have written this as a u. I'm jumping ahead. This is du over 3. Okay, so when I integrate that, I'm getting a big mess. Let me try to do this. Sorry, the pen got all cloggy. All right, we're integrating the cosine of u, and this is du over 3. So I'm off by a third. The integral of cosine is sine. 1/3 is the constant multiplier, if you will, so that stays in front. And then just don't forget to make your replacement. I feel like this is a lot of writing, and some of you just might jump right to the answer. Okay, let's try that over here. This in a little bit. Okay. All right. I'm going to integrate this. 1 is I threw that in there to kind of mess with you a little bit, but to integrate 1, it's just x. And then 3 is a constant multiplier. I'm going to do this using all shortcuts. 3 is a constant multiplier. So wait, when I integrate sine turns into negative cosine. So this is going to be negative 3 cosine. I'm going to leave my 5x. But I'm off. I'm off by what? I'm off by a 1/5. I don't know. I totally did that super duper shortcuts. I don't know. You can do substitution too. Okay, moving on. Shall we keep doing these? I'm going to do all these kind of fast. All right, so cosine, we decided, turns into sine. But I'm off. I'm off by how much? I'm off by the reciprocal, which is 4 over pi. Let's do that game again down here. These all organized. Sorry, I like it to look good. Okay. All right, let's keep going. This one, let's see, when you integrate sine, you get cosine. Oh, actually, negative cosine. So, yeah, so this is negative cosine. I'm going to leave a little gap there for a second. And this is, but I'm off, and I'm off by how much? The reciprocal of this, which is just 6. Stick that right in there. Looking at this one, cosine integral is sine. See, this is nice when there's only like a little coefficient. But I'm off by how much? I'm off by a half. You know what's great is you can also test these and work backwards. Take this actual derivative and be like, oh, what is the derivative of this? The derivative of sine is cosine, and then the derivative of 2x using chain rule would be times 2, and that's how the 2 and the 1/2 cancel. Does that make sense? I hope. You can just do all these backwards using derivatives. Okay, and maybe they're not going to be x's, maybe they're going to be y's. So 6 is a constant multiplier, it comes down. I'm off by how much? I'm off by a 1/5. I'll put that right there. But like I said, you can do this going backwards. Maybe I'll do that in a different color. So if I was to take this derivative, the derivative of this would be constant multiplier, leave it, you write it like this, and the derivative of 5y is 5. And then the 5's cancel, and you're right back to where you began. Do you see that? So every single one of these can be done in its reverse. Oops. Okay, let's really do a little bit more here. Okay, I'm sorry, but these are so good and they're going to get really, really good. So please hang tight. We're almost there. All right, so again, let's try something like this. If I let u be x squared, du dx is 2x, and look, I'm not off by, if like, it's okay to be off by a coefficient, but I'm off by a full-on x. Like, this x here is not going to cancel, so this can't do this one. Okay, there's no way to do this one right now. See, now over here, I can now say, ooh, there's Maple. She sees somebody out the window. Did you hear that? Okay. Okay, x squared. Du dx is 2x, so dx is du over 2x, and I'm psyched because it's going to cancel. This is a u here, and this becomes du. I tell you, after this, you're going to be like integration by substitution pros. These x's are going to cancel nicely, and I'm left over with just a cosine. And when integrating this, that 1/2 is a constant multiplier. I can hang around. The integral of cosine is sine u plus c, and then you just make your replacement. So just be really mindful of how things can cancel and can't cancel. So this is a good screen here because this one you couldn't do up there. Okay, moving on. All right, so here's some ln stuff. All right, yikes, here we go. All right, whenever I see this, I think, all right, let me bring it up and write it as x minus 1 to the negative 1 dx. So when I see that, I'm thinking, oh, I can do anything to the negative 1. Maybe I should write that over here. The integral of 1 over x dx is the ln of the absolute value of x. Okay, so you really need to have maybe that written down next to your paper. Okay, so if we let u be x minus 1, du dx is just 1, dx is du. I'm not off by anything. Like, I'm not off by anything in this one. So when I go to integrate this, I'm literally just integrating u to the negative 1 du. This is such a good problem. All right, so when I integrate that, I'm just getting the absolute value, the ln of u plus c, and then I just sub it right back in. All right, so now coming down here, this one, you can see the difference between these two. I kind of wanted to put them on the same page so you can compare. Again, here I am, I'm integrating, bring this up, and if you look, oops, if I bring that up, now I can, again, I'm going to let u be 2x minus 1, which means du dx is 2. And I am off by a little something. Okay. It's d, oh, yeah, over 2. So when I go over here and I integrate that, it's now u to the negative 1, and this is du over 2. So I have this 1/2. You see I'm off by the reciprocal of that coefficient. So this is going to be 1/2 ln of the absolute value of u plus c, and then I just got to put it back in. So 1/2 ln 2x minus 1 plus c. So that's my final answer. Whoa. Okay. All right. Moving on. Kicking it up a little bit. Every time I figure if you just keep watching, you'll get tips. All right, so I bring this one up, and then I'm like, oh yeah, now I can clearly mark what is the interior here, and I'm happy because that x will cancel. I'm solving for dx. dx is d over 2x. So when I come back over here, the x's go away, which I need that to happen, and I'm really only integrating, let me cancel those, see, x's go away, and it's just the integral now of 1/2 u to the negative 1 du, which is the absolute. I'm going to actually make the substitution in right now because I don't have room. Okay, perfect. Are we seeing patterns? I mean, maybe we can integrate this one fast. I don't know. Let's just be careful though. I definitely want to bring that up. And I'm integrating 2 minus x to the negative 1 dx. So see, there's that famous negative 1. So it's going to be the ln. But if you noticed, let u be 2 minus x. du dx is negative 1. I'm actually off by a negative. It's that coefficient again. I'm off by a negative. So dx is negative du. So I'm integrating u to the negative 1, and there's a negative du. I'll put the negative right there. So this is negative ln. I'm just going to put the replacement in all in one step. Okay. All right. So here's the case where every time I brought that denominator up, it went to the negative 1. So just remember, anytime you're integrating like 1 over y dy, because you're going to have to do separation of variables. So you're going to have y's and w's and who knows what letter it's going to be, but it's going to turn into this. Oop. Okay. That's the whole big conversation. All right, let's keep going. Now, it's deceiving. Everyone gets into this happy ln mode here, but it's actually not ln in this situation. Again, you bring it up, and now it's to the negative 2. I'm not off by anything here. See how that coefficient? I mean, I can mentally do this in my head. Let u be x minus 2. du is du dx is equal to 1. So du is dx. I am not off by anything. So whatever. It's just u to the negative 2 du. And when I add, see now this is not to the negative 1 power. This is to the negative 2. So if I add 1, now I get negative 1. So this is classic polynomial integration. Add to the exponent, divide, plus c. Here's my answer. Maybe I need to write it like this. Yeah. Okay, let's do another one in a different color. Okay, so again, I bring this up, and I have 2 minus x, so -2 dx. Let u equal 2 minus x. And see how they sneak in? That you are off by a -1. Oh, I guess I'll put the negative there. I did that backwards. So really what I'm integrating is a negative u to the -2 du. Okay, let me just make sure I'm doing that right here. So this du, yep, got replaced. There's the negative, and they got a little sneaky. I've seen this before where kids get so quick to think it's not off by anything, but it is. It's off by a -1. Okay, add to that exponent. I get now -1, and then -1 divided by -1 is a +1 plus c. So here's the final answer, 1 over 2 minus x plus c. I made my substitution. Okay. All right. So these are wicked, wicked important. Oh my. And this is my last screen. I really hope you're still with me. So going by what we talked about, I'm going to bring this up, and I get 1 plus x squared to the -1. Okay, just showing you some stuff. If I let u be 1 plus x squared, do you see how we have a problem? We have a 2x. I'm off by a 2x. So if I try to make my replacement, it's not going to cancel. Do you see? Like, I don't have an x out here to cancel. But you're going to have your trig, inverse trig things in front of you. And if you ever get stumped in your integration, be like, why am I stumped? And then hopefully you will think to yourself to peek at your little notes that's in front of you, and you're going to realize that this, my friends, is the inverse of tan. So this right here is this. Okay. And all of these on this page are in the same situation. This, looking at, and I don't even have these memorized. I really don't. So I'm glad I don't have to memorize them. And you don't either, but you have to be aware of them. But if you try to bring it up and you try to do substitution, you're going to realize that it is not canceling and you're in trouble. So that's the whole point of this conversation, is that this can happen. Slide this down a smidge. This one happens to be the cosine. So go ahead, you try to bring it up. You're going to let u be 1 minus x squared. Therefore, du dx is going to be a -2x in this problem. And -2x is not canceling with anything unless there was like an x up here. Now, if there was an x up there, then it would cancel, but it doesn't. How do I undo that? Okay, good. And then the very, very last one is this one, which turns out to be sine inverse of x plus c. Okay. Yeah, that's my crash course of integration by substitution. I really hope I helped. I hope it helped. Watch this video now. Watch it again, like the day 2 days before the exam. Like, watch it again and again. Practice a few, take screenshots, whatever it takes to have this in front of you. Okay, good luck, guys.